Okay. Thanks everyone for coming. Welcome to the February 3rd meeting of the THP Cabal. We have a number of people who sent apologies this week. So that's fine. Let's see. Well, a lot of excitement last couple of weeks with the work from Intel on setting multiple PTEs or mapping multiple pages from a folio at once. That's looking really promising. I think there's still some rough corners we worked out there, but I'm really pleased with the results we're seeing. For anyone who's not paying attention to that, we're seeing about a 2% performance improvement on a Willett scale benchmark from batching the updates to the folio ref count, which frankly I'm surprised was noticeable, but I guess we're hitting the same folio ref count often enough that it's worth doing. And then a 15% improvement from batching the updates to the LIU, the per LIU stats. So that'll be, telling it that how many pages have been mapped within that LIU. I'm a bit less surprised about that. I thought.
Sorry, Matthew. Where Folios comes from in this case? I'm not quite follow.
Oh, so this is XFS. So these are file.
Okay.
Go
that's we had for read-only for XFX and a bunch of other file systems, right?
Yeah, I think we're up to 3 file systems currently supporting large folios: XFS, AFS, and ZoneFS. I have some interest from the GFS2 people in at least trying out whether it currently works. I have a few small patches to hand to them, and then I think they're going to go off and test it.
Would be interesting to see how it play out for Team PFS, where we can force large folios. Will it be like dramatically different?
Could be, yeah. I presume that the benchmarks will all be run against XFS, but you're quite right that Shmem or Tempefs should also see the same kinds of improvements.
If I can get my CIFS patches finally upstream, it should be possible to turn it on in CIFS too, I think, because basically replaced all the list of pages with iterators.
Cool. Yeah, that'll be really good. It will be quite funny if all network file systems get large folio support before most of the block file systems do. Yeah, buffer heads remain the sticking point for most of the block-based file systems. I mean, I think we really do need to have folio support for the block-based file system, which is what I've been working on. But large folio support is going to be really hard, and I think it just may not happen, which is kind of a shame. But it's the more I dive into it, the more places that it's like, oh yeah, and the buffer heads code assumes that there are only 1 page per folio.
By large folio, you mean PMD mapped folios, or
not necessarily? Just more than 1 page.
Ah, okay, I see.
Yeah, you'll see various things like arrays declared on the stack of number of blocks per page, and it's like, well, we can't really. I mean, we could switch to a dynamically allocated array of pages, but array of blocks per page. But I mean, how much work should we be putting into the buffer head code, and how much should we just be persuading file system authors that hey, it's time to switch to IO map?
You mean you don't want your entire floppy disk mapped in a single folio?
You know, we talk about. I mean, the thing is, it's not just floppy disks, right? It's ISO 9660. But I mean, even something modern like ext4 is still using buffer heads, and you know, you can easily have terabyte file systems with ext4, or for that matter, Btrfs. Well, okay, Btrfs is a different matter. Btrfs doesn't use buffer heads, but Btrfs has its own interface to the IO layer. It's I think it's purely page cache based at this point, but we still need to go in and actually make Btrfs support multi-page folios, and you know that's work I haven't done yet. I keep hearing rumors that Btrfs is going to switch to IOMap any day now, which would be great. But I don't think IOMap actually has all the features that Btrfs needs. So I think those suggestions may be overplayed. So I don't know if I have a, well, actually, no. One of the things that is going on with the work from Intel is we kind of need to define a new API for setting multiple pages in a folio. So there's an interface right now for each architecture that says it's called set PTE at, which sets a single page table entry. And right now the Intel patches are doing a loop over that and setting each one, which works and gives a performance improvement. But we're leaving some performance on the table for some architectures. I think ARM specifically, and perhaps RISC-V in the future, some other architectures perhaps.
AMD already has it as well.
So what we're doing will work for AMD, because AMD don't need you to set any special bits in the page table entry.
Right, it's opportunistic, yes.
Yeah. Whereas with ARM, you have to tell the hardware, hey, this is actually a 64K page. Go ahead and insert a 64K TLB entry. And so to support that, we need this new interface. But yeah, what's being done will work just fine for AMD hardware.
So what does this actually map? Is it only for mapping huge TLBs? So huge pages, sort of like 2 megabyte jobs?
No. So that's actually handled at a different level. So if we determine that the folio is large enough to be mapped by a PMD and is appropriately aligned to be mapped by a PMD, there's a different interface we call that sets a PMD entry specifically. What we're talking about here is the cases where that isn't going to happen. So either the folio is too small or it's not aligned correctly. And so what we want to do is we want to say, so we've taken a page fault and we found the folio that contains that page is larger than a single page. And so what we want to do is we want to map as much of it as possible at once, because I mean we've taken the spin lock on the page table. We may as well fill in as much of it as we can.
So it's just really about batching PT entry additions. It's not...
So basically it's fault around.
Right.
And given that we know, go ahead.
Can we use this for KMap as well?
No.
Right.
So the problem with KMap is completely different. KMap is that we have only a fixed number of entries, and it's something like 16 or 32. And so a folio can be larger than that, so we can't KMap the entire folio at once.
Right.
So I've sent out patches that abuse VMAP to do it, but people aren't really happy about that because VMAP can sleep, whereas KMap doesn't. I don't know that there's a good solution
Get everyone to move to 64-bit architecture.
Yeah, I mean, burn it with fire is a great solution, I think. You know, every year there are fewer and fewer systems available that have high maps, so.
I have a point back, like the actual API that you might want for setting a bunch of PTs. So for huge TLB high granularity mapping, which is what I've been working on, for like to handle contiguous PTEs, like I had to do the huge PTE, set huge PTE at function differently, because like before the architecture could just check huge page size of the H state. Whereas now the PTE could be any size. And so we have to pass the size of the PTE with the PTE itself. And so I had this struct, like this huge TLB PTE struct. I think you might remember that. And so it contained the size, the size of what was being mapped.
In this interface, the problem will be with locking, because like even if you pass down that this like you want PMD here, but if caller need to take appropriate lock, so it doesn't really makes much difference.
Right. So the way that locking is handled is that it's also stored in that, like the page table lock that is supposed to be used is also stored in the huge TLB PTE. And I mean, we have to be careful to always make sure that we use the correct page table lock. So like if you're messing with a contiguous range and at the same time someone is messing with PTEs within like that contiguous block of PTEs, like you have to make sure that people aren't, stomping on each other. And so there's a little bit of code to make sure that the page table lock is actually correct. But so that's the API that I thought would work for ARM or for any architecture that supports contiguous PTEs. And I had a separate question just about like, what about set PMD at? Like for huge TLB, we don't have a problem because no matter what size, we always just have set huge PTE at. But for generic MM, you've got set PTE at and you've got set PMD at. So like ARM64 supports contiguous PMDs.
You asking why we have different functions for them or what? I'm not quite
No, I'm just saying like Matthew was talking about like batching PTE updates, but potentially you could also batch PMD updates, but I guess THPs are only 2 megabytes as far as I know, so maybe it's not super big deal, but I'm just curious what your thoughts on that were.
Yeah, I actually touched on that in the last email I sent in that thread, that while we're doing this, we should also do a batch PMD version. And yeah, right now, file folios are limited to PMD size, but that's because I don't. One, we get most of the benefit from like sizes intermediate between PTE and PMD. There's less advantage to be gained by going larger than the PMD. And the other is that there's all kinds of places in the VM that assume that if you're mapped to a PMD, then you are necessarily a head page. And I don't have the fortitude to go through and fix all those places yet. I'm kind of fixing them as I find them. But actually finding them all is going to be a pain. Partly because it's really rare that you're actually able to create a folio larger than a PMD.
And I think this use case for this kind of interface for PMDs will be very limited. Like even for PTs, it will be limited to like fault around and maybe map populate or something. We will not have a lot of cases where you actually need this interface.
I think there may be more cases than that. There's some device drivers which would benefit from it. Indeed, there are some device drivers which currently do it. Like they sort of do it manually rather than using the batch interface. One of the Intel graphics drivers I know does its own implementation of fault around.
I guess it's flavor of map populate, no? Like when you prefill your mapping.
As I recall, it waits until fault time and then it does a few pages around where you faulted. But okay, I haven't looked at that code in probably 10 years.
Okay, and one thing that to have in mind is that fault around and things like that had like downsides when you, like I believe on ARM they end up disabling it because of access bit. So they take toll on I don't remember exactly what was it, but basically, if you don't have hardware bit for access, there is significant overhead to get fault around and have map pages that you don't really need. And yeah, they explicitly disable fault around, for instance.
Yeah, we disable it at Google. We have some hacks just fully disable it everywhere.
And for what reason? You just found is that it slower your way, or?
A lot of customers complaining about excess like memory bloat, but
Okay.
This is yeah, a number of years ago and hasn't since we rose it.
It's x86 or it's ARM or what? Or it's everywhere?
x86. Everywhere.
Oh, okay.
It'll be interesting to see how different modern hardware is going to affect that. Because right now, that's interesting. I think with the current patches we're looking at, you would actually end up disabling all the fault around. So even if you get a multi-page folio, you'd only see a single page of that folio mapped because you're disabling fault around. But that may change as we go through. Right? But we may understand, the fault around didn't work. But then when we actually read the folio, we got a multi-page folio out of it. Maybe.
I feel that it will be a nightmare to get it right, and or we will end up with a lot of handles to tweak it. Yeah, I don't want to have it.
Something I think we probably should talk about is what to do about cow pages. Because right now, when we do a cow, we always allocate a single page. But we know that managing single pages is ridiculously high overhead, and we're much better off managing memory in larger chunks and single pages. The question is, are we going to start doing cow of more than one page at a time?
I think it's risking of breaking something, because somebody can realize that you will see what changed in the neighbor page that was never touched before. Something. So yeah, I understand that POSIX allow for private mapping to be static, but in practice, maybe somebody realized that if you have private mapping and you have never touched this particular page, and somebody else modifies the same file, you will see the change.
But cow can always, a private mapping can always be copied at fork time and not necessarily at write time. You're not guaranteed to get cow semantics.
If you never forked,
if you never forked, okay, so you're talking about a map private and you never forked. Yeah, I think anonymous memory behaves differently here, but file.
In the manual page, it says it's unspecified as to whether further changes are visible to you.
Yeah, but it's like a long-standing behavior, and I expect that somebody will complain if it change.
But then it's going to have different behavior on architectures with different page sizes.
Right. If it's this piece of software ever run a different architecture.
PowerPC, where you may be running on a 4K page kernel or a 64K page kernel.
Or ARM, same thing.
Yeah. The user space has to cope with different size pages. And with PowerPC, you might be running a 32-bit application on a 64-bit kernel. That's actually fairly common. Just to add to the fun.
I guess we can try, but yeah, it will be horrible to see that it will break something like when this change will hit some LTS kernel down 3 years or something.
I mean, we could always introduce a PR cutoff to turn it off for a particular process.
Yeah, but it means that you will need support both cases, and it's not great. Yeah, I guess.
Well,
so.
I think the Folio code handles that abstraction. I mean, we would actually want to fall back to allocating order 0 pages if we're under significant memory pressure and we can't get an order 2 page, for example.
Okay, fair enough. Yes.
But I think we always need to handle order 0. I think the question is how do we attempt to determine whether allocating a larger folio would be beneficial? And what size?
Sorry.
Go ahead.
I was going to say there was a related change here, right? I think for anonymous THPs, Cow used to do the whole thing, used to copy the whole thing, but now, like recently, something like a year or two ago, it was changed to do it.
It's more than that, yes. I made it the same as for file pages, where it was always 4K on copy and write.
Okay, yeah. I guess I'm bringing that up because I guess me and Zach noticed a couple months ago, and so I don't know. Maybe that's unhelpful, but just want to remind you. Like we noticed a significant performance regression for VMs running a particular workload.
Let me just check I understood that correctly. You're saying that carrying an entire 2 megabyte page was better performance than carrying an individual 4K page for that particular workload. The
reason it was better, and so this was all basically just the guest kernel got updated, and so it got the new behavior. So this workload was reading a bunch of anonymous memory and then writing to like all of it. And so before it would immediately have 2 meg huge pages. Now it would have to wait for k huge page D to do a bunch of stuff.
Yeah, we actually have I was meaning down the line, it's not super high priority right now, but at some point I was gonna, we definitely have customers internally which are asking for some sort of hack to restore the old copy on write semantics for the 0 huge page for anonymous memory. I don't have a solution for it or anything. I just know that at some point I need to deal with it in one way or another. But yeah, there's a couple customers which have specific workloads which like to rely on the fact that they can reliably read zeros from 0 huge page for a while and then subsequently be able to fault in an actual huge page. Yeah, and so at some point I need to come up with a solution to that. I don't have one, but at some point.
Well, I'd invite you to consider my suggestion of a PR cutoff to allow that kind of control, because it does sound like something that needs to be a per application thing.
Yeah, I was thinking my first thought was just that copy on write semantics for, you could just reuse more or repurpose MapV huge page, I guess, and so like copy on write for MapV huge pages that are actually huge pages would try to fault in a huge page rather than a 4K page. First thought.
That's exactly what I was thinking. Yeah. Sorry, Zach, to interrupt you, but that was really confusing for us. Like we had M&V huge page on these VMAs, but we still got 4K pages, and it was super confusing.
That's a better hint for PR customers if somebody's amortized huge page.
Or maybe it's better to solve with some M devices, like we have M device collapse nowadays. I'm not sure, but maybe we should, I don't know.
Sorry, what's the suggestion there?
Yeah, I try to think of anything nice, but yeah, I guess per SSL works or per VMA settings, but yeah, it's the reason I changed it initially, like besides the mapping between like matching semantics for file and anonymous copy and write, is there was some complaints about copying 2 megabyte at once. Like it's opposite to your use case. There was some Redis or something, I don't remember exactly, where they doing backup by forking the process and reading the anonymous memory and dumping it to disk or something. And if other process will touch the memory, they don't want to have like full 2 megabyte copied. They want like to have 4K and not consume too much memory for this temporary stuff.
I guess a related thing, because we're sort of talking about M&V things. There was some discussion about M&V split, sort of like an analog of M&V collapse, or I guess the antonym of MNV collapse. And like for HTLB, like the API for high granularity mapping was sort of being discussed, and it seems like Mike Kravitz and Peter Shu thought that MNV split to enable like HGM APIs was like, you know, being able to do UFFDIO continue at 4K, stuff like that. Using MNV split to enable that made sense, but there isn't like that doesn't really mean anything for TempFS right now, or well, generic MM right now. And so I'm curious if that's something that we want to talk about, like, or Zach, if you want to talk about that. I don't know.
So you
sure,
want
okay, go ahead.
modify split for splitting THPs or what?
Well, I see. I don't really know what people would use it for. Like, I don't know why someone would want their THPs to be just split in a steady state if they could otherwise be huge. So
yeah. So we have two use cases, and thanks for bringing up. I mean, it's one of the things I was at some point I was going to bring this up in this kind of meeting and get folks' thoughts on it. There's at least two cases where we care about splitting huge pages. One is for, and then they're two very different use cases. Yeah, one is just splitting the PhD to do access bit tracking. So we have a bunch of like, you know, if we have some sort of like access bit monitor tool, whatever that does access bit tracking, it might be advantageous to split the PMD to do tracking at the PT level for a little bit to actually know what, like, are you still making good use of this THP, or is it like only like a couple pages that are actually, you know, hot or something like this? So that's one use case. The other use case is, and so yeah, that one would just be splitting the PMD but keeping the compound page intact. There's another use case which was brought up a while ago, and which is something that eventually I wanted to talk about, which was using in combination with MADV don't need. The way long ago context, actually I'll because I'm looking at it right now, I will copy the link and copy link URL, and I'll just paste in the chat just for context for a while ago. But yeah, the other use case that's been brought up was by Peter Shu for use with MADV don't need, because right now, yeah, there's a couple changes like back in like 4.5 where there's some changes to like ref counting for THPs, and one of the side effects was for MADV don't need, or it was introduced as this whole THP deferred split queue thing. Which has caused, you know, issues at Google for the last couple of years, and we've had like hacks internally to like deal with it, but like even that's like coming to like some sort of like, you know, we want a better solution, not rely on hacks, like work with upstream to actually come up with a better solution. But the crux of the problem is that you know, MADV don't need when applied to a proper subset of pages of a THP. So that you'll end up in a state where there's some pages that are mapped and some pages that are unmapped. The THPs get put on these deferred split queues, and our process RSS, you know, decreases approachably right away. But it's like it takes a while before the pages are actually freed, and the MemCG is uncharged for those pages. And so this kind of, so it's two things. Like one, it's this like there's unmapped memory that the page that these MemGs don't have access to, and two, they don't have any visibility into it. So there's no stats right now. It's like say, hey, this is, you know, there's this memory that, you know, you can't touch, that we'll get freed under reclaim. And so Shaquille, a couple of years ago, proposed basically reverting MADV don't need to its previous behavior and doing the compound page split synchronously. You know, there was a few issues with it. You know, it definitely added a lot of latency, which, you know, people were worried about. I think, one of the solutions that Peter Shu mentioned was, you know, basically using this MADV split to pre-split the compound page, so that a subsequent MADV don't need would actually free the sub pages right away. There's a couple. Yeah, that was basically the context in which that version of MADV split was discussed. Matthew, I think you weighed in on that a little bit, talking about the, you know, when is it appropriate to split huge pages, and like what should you be doing when you split the huge pages, Like, if you know that you're splitting this huge page, should you be migrating like the existing content somewhere else to keep the, the huge page like intact and not rely on, compaction, come around and reassemble it later. So there's a bunch of like issues surrounding that whole thing. But anyway, belabor the point. That was the other context that MapV split was thought to potentially be useful. But yeah, I think now is a good time for us to actually start thinking about it, now that you're potentially adding in a MapV split for a huge TLB like use case, like and given that the advised mode might actually just be in there, it might be a good idea to figure out how to transcript or to repurpose it for a THP use case, kind of like how you did with MapV collapse and repurpose it for huge TLB. If any of that made sense. Sorry.
Yeah, so we basically need to also draw semantic difference, what we split, page under it or PMD or whatever. And there are other things that I was not sure how to rectify is interaction with khuge-paged. So you just split the page or PMD and then khuge-paged came in, brought it back. So I guess it's up to user to do it in the right way. Like if you don't want page to be resurrected, then you need to also like apply advice. Yeah, I don't know. On the other hand, maybe we need to work harder to make kernel just work and not expose more and more handles to to get it right from the user space. I don't know.
Yeah.
So a couple of interesting things there. One is that if we're doing this in order to track access bits differently, we actually do need to split the entire page. We can't just split the PND because we don't have an access bit, or at least we don't ever look at the access bit on tail pages. It's going to be the case we don't have an access bit on tail pages. This is a portfolio bit.
I guess it was about tracking hardware access bit, like in page table entries.
Yeah.
Yes, but if you have a THP which is mapped by PTEs, then when you do a scan, all those PTE bits get cleared and we update the single folio access bit, so you don't get a chance to really find out which bits are in use and not.
I'm sure Google use those bits in different ways. They not just transfer it to state on LRU or whatever.
Well, and I'm looking at the patch that Shaquille posted. It does in fact split the page and not just the PND.
Yeah, yeah.
The other thing I wanted to say is that you make a really interesting point there, Kuel, that perhaps the kernel should just be doing better at this than and not requiring user space to have all this extra smarts.
Maybe, for instance, we need to be more proactive on like the fair split list and not leave pages there indefinitely, and like have some upper limit on and have whatever thread to split them in background or something. I don't know.
Yeah,
that's one way to approach it.
Yeah, we've had a background thread just go and every couple of seconds proactively split things. And yeah, we've had that running the fleet for the last couple of years.
But maybe we should move that intelligence into the kernel.
Well, I mean, to be honest, we have this kind of thing running at Google right now, but it's still causing issues. So we're hoping to come up with a better solution than that, because honestly, I mean, it's running every 2 seconds right now, but it's still causing issues for customers that mostly database people, that folks that like really manage their, want access to all their pages and, fly pretty close to the sun. And they just can't wait around, like even for 2 seconds, they get unhappy about that. So they really want, when they MadV don't free something away and say, hey, like, I don't want these pages, like, please stop charging me for them. They don't want to wait 2 seconds. But yeah, this is a solution that we've been using at Google for a while. And we're happy to upstream it in some way if we think that it is somehow the best possible use case that we can think of. But ideally, we know it's already causing problems for us, so hopefully we can come up with something better.
Oh, so that's a really interesting point. So you said, let me just check that I understood what you were saying there. So the problem here really is that some customers use mAdv3, but because it's part of a THP and they haven't freed the entire THP, they still get charged for the entire THP, and we just ignore that mAdv3 call.
Did I say mAdv3? I meant mAdv don't need, but yes, basically, yeah.
Okay, so I made this point recently in a thread with Hugh. I think we need to take mAdv don't need, mAdv3, whichever, as a hint that we've got it wrong, that this shouldn't be a THP anymore. So mAdv3 should split. It's really my assertion.
Yeah, mAdv3 does. mAdv3 does do asynchronous. It'll go through and it'll split the huge page. It'll split the PMD. So mAdv3 does good stuff. But yeah, we actually have to wait until memory pressure before it's actually before the page is actually free. Where mAdv don't need does give like the behavior we want in terms of like it unmaps things right away, and but because of like some locking context, we have the deferred split list, and the pages aren't actually freed until the deferred split list is processed, and then at that point the MTGs are actually uncharged.
One question: you saying that like the customer is still charged for the memory? Is it a accounting issue? Like, can we just solve it on accounting?
Yeah, that's it's a very, very good point. I have a document right now I'm looking at that basically proposes, doing some mAdv, on one hand, doing some mAdv3, whatever, or like advised trickery or something to solve it in terms of like synchronously splitting the THP in some way, shape, or form. There's no real good answers there, I'll be honest. And the other one is, yes, you're absolutely right, solving this is an accounting issue, and like adding something to memory.stat somewhere that exposes this information that the customers can then use. At least then they know that, hey, I freed this memory. It's not available to me right away, but I know if I hit my run into my MCG limit, that I'm very likely to be able to reclaim that memory. So that you're perfectly right. I think that is another possible solution. At least at Google, we would probably still have to people probably aren't happy about still relying on reclaim in order to actually do the split, because then you might get some latency critical thread that is the unlucky one that ends up having to sit around and do the work. I think treating it as an accounting issue and then exposing some of that data would certainly help.
One other point is that I'm not very comfortable with splitting page hash pages in this manner with just mAdvice. At least it has to be like for the files that user has write access to, because it's not owned by a single process like anonymous memory. And I'm not sure how to solve this. Like if you have, for instance, some shared read-only dump or something, and multiple processes access them, and yeah,
that's a good point.
Yeah, we could put some interesting guardrails on that for file pages. Like if this is the only open of if the file only has one opener, then allow it.
But opens comes and go, and it's also not. Yeah.
Yeah, or maybe if you're the file, if this process is the file owner, or
I guess write access should be enough to guard this. I don't know.
Yeah, because if you can F truncate the file and force a split. Yeah, I mean, fundamentally, it's up to the page cache how it wants to handle, how it wants to cache pages, right? And it's relying on user space to give it hints, but they are only hints. That said, C groups complicate this, right? Because the application says, well, I only want to use this much, and page cache says, no, I disagree. You're using all that much as well. It's like, yeah, that's tricky.
Yeah, I've been thinking, I've been noodling about this a little bit, because honestly, yeah, we had recently a big issue at Google around this. So I'm kind of frantically trying to put a proposal, and I was, in the midst of trying to bring up a discussion about this with the upstream community. Yeah, candidly, I can't find a great answer. Yeah, at least in terms of like user space having control to kind of do this manually. Yeah, the point about the page cache is well taken. I didn't even think of that. Would this be something that is like, in lieu of coming up with a solution that does provide user space with the ability to kind of manually take things over and do exactly what they want? Does it just exposing this as an extra accounting stat? Is that something that folks would be amendable to? I think we already have like stats, like exposed stats about like THP deferred splits and stuff like this. So it's not like it's leaking any new abstraction. But yeah, the idea would just be an extra stat line in memory on stat. Yeah, part of the problem there is, I mean, quote unquote problem, I don't know, is that even when you have a THP on the preferred split queue, like you don't actually know, at least from the MMCG's perspective, or I guess the same perspective, but like you don't actually know how many of those sub pages have been unmapped. So you don't know how, like when the THP, like when the thing was actually processed on the deferred split queue, how many pages are actually going to be freed. But at least it provides like a bound, right? It's like, hey, I have this many THPs on the on like the first split queue. I know I'm going to get back between this much and this much memory when they're processed. It's something. It's better than nothing. At least that way, that at least we have customers that would use it to some extent. I don't think it's exactly what they want. I know they want some hackery to put in there to split things right away and get their memory back immediately, but But anyway, we don't necessarily need to solve it now, but it is a heads up, I guess, that at some point, probably in the near future, probably not today, but probably early next week, I'll probably send some sort of request for comment thing that outlines some of the issues that we're facing and some of the potential some potential solutions. Because it's something that we'd like to find a solution for.
Yeah, definitely an interesting problem. You're right. We're not going to figure out an answer to it today.
Yeah, I think one of the problems was like, I don't know, at least on that thread that for Shaquille's thread, was just it's hard to know exactly when it's a great time to split huge pages, because you don't know how they're going to be used in the future. I think David Hiddle and Brian's like use case of the VirtIO balloon, basically like using Madview don't need in a manner where like they know they're going to free the huge page or the THP eventually, versus folks which want to keep using that memory. And I don't know, I feel like it's a space where like no one's going to be like particularly happy with the outcome. Or like, let me put it that way. There'll be use cases which will suffer regardless which way we go with things.
I in general have hard time reasoning about like anything reclaim related. It's like minefield. You don't really know how to evaluate any change in this area. I know that Mel somehow do this, and somehow he has workloads that he used to evaluate it, but yeah, I don't know. Every time I try to reason if this kind of behavior in reclaim good or bad, yeah, it depends. Answer usually.
Yeah. Well, anyway, yeah. Look out for the list and we'll hash it out. I'm sure we'll get feedback from all the folks. But yeah, thanks James for putting us down this path so I can get some initial thoughts from people.
This was a good topic. We've got 5 minutes left. Anyone have anything else they want to bring up quickly?
I kind of wanted to. Oh, I'm sorry, Siddhartha. Go ahead.
Yes, Sid.
I was just going to ask about the huge CLB unification with the page cache. So right now it uses the index of the huge page size. So index 1 is the first 2 MB page, and index 2 would be a second 2 MB page. But if we change that to the base page size, then index 0 through 511 maps to the first 2 MB page, and then so on. So then looking at how I would do that is, would I add more insertions? Because each huge CLB active page cache is doing a 2 MB index. So if I change that to the base page size, each insert now becomes 512 insertions.
So if you go look at the guts of add to page cache, you'll see that it interrogates the folio as to what size it is, and it does the requisite number of insertions for you.
In file map, add to page cache?
Yeah, in file map.
Okay.
Yeah.
Okay, I'll take a look at that.
Yeah, I think for this, you need to remove the specialization that exists for huge pages, and then everything should just work. But there will be other places that need to be adjusted.
Okay.
Michelle, do you have anything quick?
Nothing much really. Just like you mentioned, I'm kind of looking at splitting out the page table stuff and making that its own struct. Just kind of getting the hang of how I want to approach that.
Cool, thank you. Zian, did you have anything?
Not this week.
Okay, thanks. Bill, did you have anything?
I don't have anything, but I just wanted to take a second to say that I've always been more of an advocate of trying to get the heuristics into the kernel to do more of this stuff automatically, and then have an option to shut it off on a user by user basis if we need to, because that usually seems to provide better benefit than trying to convince users that they need to write their applications to use these new features.
Yep, that's my position too. So thank you. I always like having somebody else with experience says, "Yeah, do it that way." Yeah. Okay. Yeah, I want to have a chat about compound compound map count, but we are definitely out of time for this week. So perhaps we'll bring that up next week, or I'll just encourage you to reply to my latest thread about that on the list. Yeah, it's 1 minute to 1, so I think we'll wrap up now. Unless anyone has any final words. All right. Well, thanks everyone, and talk to you again in 2 weeks. Bye.
Thanks.
Thanks, Matthew. Stay warm over there.